Thanks a lot for being here, for joining my session. My name is Jakub Szymaszek. I'm from Azure Databases. I'm part of the team within Azure Databases that is security and governance. Among few things, we create new security technologies that allows you to implement various security controls around your data. And today we'll be talking about the latest innovations, the latest capabilities we developed around confidentiality and integrity protection. Actually, the key topic for this session, the center theme, if you will, is data sovereignty. It's about how you can stay in control of your data even after you move it to the cloud. Of course, when you move data, upload the data to the cloud, you naturally give up some control. So the challenge here is how you still can retain that control and confidently move even your high-value, super sensitive data to the cloud. And of course, protecting data confidentiality, protecting data integrity are the key components of that. And we'll be talking primarily about 4 technologies. Starting from the bottom, 2 of them are fairly new, entirely new, Ledger and SQL Server in confidential virtual machines. And TD and Always Encrypted are not so new, but we have made quite a few recent enhancements to these technologies, especially TD, but also Always Encrypted. So we'll talk about all that. Starting with data sovereignty, Microsoft's stance around that is very simple. Your data is yours. Microsoft doesn't look at your data unless there is a very valid and serious reason for that, such as, for example, there is a data corruption issue that we need to fix. Right? However, with features and technologies such as Microsoft Logbox, you are involved in the approval process. You have to give us your consent, your approval, so that we can even look at your database, connect to your database, and fix issues like data corruption issues I mentioned as an example. And we apply to principles such as just-in-time access. In fact, as you might know, Microsoft adheres to about 50 or 60 various compliance regulations, compliance standards. We are regularly audited, and the outcome of these audits are numerous compliance reports. They may apply, some of them hopefully apply to you, and you can review them. There are details of our processes described there about things we do and we don't do. And I have an extensive list of them at the end of the presentation at one of the resources slides. Now, security and data sovereignty in particular, it involves processes, people, and technology. In fact, these are team disciplines, if you will, right? Security, data sovereignty, that involves multiple parties. This slide describes what Microsoft does and what we don't do. But then you have to also play your role, and the rest of this presentation is really about tools, security controls, security technologies that we provide to help you achieve the goal of data sovereignty and the goal of staying in control of your data and protect your data, starting with protecting the confidentiality of your information, meaning it's about ensuring that only you and your authorized users can see the data that you store in the cloud. So I'll start with something that might be familiar to most of you. How many of you use transparent database encryption? Okay. Yes, almost everybody. That's not surprising. That's a feature that existed for nearly, I think, since the inception of SQL Server in its modern form, at least decades. It's a technology primarily designed for protecting data addressed in data files, backup files, and so on. But there is one flavor of TD that is particularly relevant for the problem of data sovereignty and retaining, from customers' point of view, control of your data. And that's TD with so-called custom managed keys. When you use custom managed keys, that means that you store the keys that TD uses, they are called TD protectors. TD protector is the root key in that key hierarchy that TD uses. That you store these TD protectors in a Key Vault or managed HSM in Azure Key Vault that lives in your subscription. You have full control over these keys, the cadence of rotating them, and so on. And you actually have to explicitly grant access for your resources in Azure SQL database or managed instance, logical server or managed instance in case of Azure SQL managed instance, to the Key Vault holding those keys. If you don't do that, your databases will simply don't load in those services. And if you revoke that access at any point of time, your databases become unavailable in those services within 10 minutes, right? So think of it as a kind of a nuclear option, big red switch. You can switch it at any point of time, and then your databases simply become unavailable, right? So that's, again, coarse-grained control, but quite effective and simple. A couple of enhancements to TD with customer managed keys that I want to call out. Auto rotation. This, when you enable it, basically it means that TD will pick up a new version of the TD protector stored in Azure Key Vault within up to 60 minutes once it shows up there. When you combine it with auto-rotation capabilities of Azure Key Vault, that provides basically zero-touch rotation experience, very easy to use and set up. How many of you build multi-tenant services? Like software as a service solutions where you have some other tenants essentially of your SaaS offerings. Nobody? Okay, a few folks, super. So a couple of enhancements that could be relevant for you. Number one is ability for your tenants, your customers, to hold TD protectors in their own key vaults, in their own subscription, while your database sits in your subscription, of course, right? The other is relevant for customers that use, achieve tenant isolation, like by putting different tenants' data to different databases. So that other enhancements are per database customer managed keys, in addition to per server customer managed keys that we have supported so far, okay? So these are a couple of enhancements for TD I wanted to call out. Again, TD is primarily about encrypting data at rest. The moment the data is loaded in the database, the protection provided by TD ends, right? So if I'm a malicious database administrator, I can connect to the database, I can do whatever I want. I can exfiltrate any data I want. If there is a piece of malware running on a machine hosting that database, with OS level access, it can exfiltrate the data from memory. TD doesn't stop that, right? The feature that was explicitly designed to protect against such attacks is always encrypted. How many of you have heard about it? Okay. How many of you are using it? Okay. Okay. 2 to 25, I'm guessing, right? Okay. I'd love to hear why 23 of you approximately are not using it. I have my theory and hypothesis around it, but I'd love to hear it from you maybe after the session. So Always Encrypted, very briefly for those of you who know it and heard about it. That's the feature that employs client-side encryption. It's a per column feature, so you set it up for individual columns that contain highly sensitive data, and it works by encrypting the data on the client side before loading it to those columns, before inserting these data to these encrypted columns, and then transparently the client driver and the app decrypts the data when it retrieves it from encrypted columns. So the point is that protected data never ends up in clear text in the database system, right? So even if the database system is compromised, totally hacked, right? The idea is that there is no sensitive data there to steal. The security is really top-notch. There is a drawback here, which is, or a very negative side effect, which is because there is no sensitive data inside the database, database system cannot really do much in terms of computations and query processing of the data, right? Because it cannot process it. And that's the challenge we, from the beginning, were trying to solve. In this initial version, we made a super tiny step towards solving this problem by supporting deterministic encryption that allows you to run very simple queries that do equality comparison on protected data and nothing more than that, right? And that is what motivated us to invest in the technology called secure enclaves. So with this enhancement, the idea is that sensitive data is decrypted inside a secure boundary called a trusted enclave or secure enclave within the SQL Server process. And so it's in clear text there, and now the database engine can perform more computations on the data because it's in plain text. So with that, we can support point lookup searches, range queries, and a few more operations. And we can also do in-place cryptographic operations such as key rotation or encrypting your data for the first time in place. No need to move it outside of the database, right? Now, an enclave, again, it's a chunk of memory within the containing process. In our case, that's SQL Server. And that's a chunk of memory with very special, cool properties. It's basically a black box to that containing process and everything else on this machine, even the kernel of the operating system. Now, there are two ways you can, vendors or different providers, if you will, implement that abstract idea of an enclave. You can do that with hardware, or you can do that with software. So hardware-based technologies are such as Intel Software Guard Extension, or SGX. We use it in Azure SQL database. And with that, the memory of the enclave is actually encrypted and encrypted, and the root of the hierarchy is stored in the hardware. So it's hardware-backed encryption scheme versus software-based technologies such as VBS enclaves in Windows, where the enclave is protected through isolation. A softer enforcement, if you will. Hypervisor in this scheme plays a key role. It basically rejects attempts to access enclave's memory, right? And we use that technology. We've been using it since enclaves shipped in SQL Server 2019. And now the new thing is that we also support VBS enclaves in Azure SQL database. But I'll start with what we did in Azure SQL database about 2 years ago. We GA'd this feature using SGX, hardware technology. And so it's still there. And the one challenge with all kinds of hardware technologies is that they require special hardware, which is not available everywhere. So to use SGX in Azure SQL database, you need to explicitly configure your database to run on specific hardware. If you don't do that, there is no Always Encrypted with Secure Enclave functionality. And that hardware has quite a few limitations. It's only supported in the vCore model. It's supported in a few regions. You can only create databases with up to 8 vCores. So there are some problems and challenges. However, it offers solid and top-notch security, and we'll get to that in a second, right? But now, oops, what happened here? Sorry, I messed something with my animation. But now, what we also offer in Azure SQL database are software-based VBS enclaves. That's new. Literally, we went to public preview, I think, 2 weeks ago. The advantage of VBS enclaves is that they have no hardware dependency at all, which allows us to make them available in all database SKUs, right? So you can make them, you can use them in both purchasing models, DTU and vCore. You can use them with serverless late databases. With SGX, it's not possible. And you can use them with any compute size, even with newly released 128 vCore databases if you want. And they are already supported in nearly all the Azure regions, except I think 4 or 5 at the moment, that there will be all of them by the GA. So what's the catch, right? The catch is that VBS technology offers slightly or for some people substantially, depending if you care about some of these attack vectors, security protection, right? So we need to probably split this apart, these different attack vectors. So Always Encrypted primarily protects against two attack vectors. One is malicious database administrators, subscription admins in your organization, right, on customer side. So both VBS and SGX protect against this attack vector equally well. That needs to be spelled out, right? The difference is in regards to attack vectors originating from the level of the operating system, okay? So for example, because software enclaves, VBS enclaves, are not protected through encryption, they are vulnerable to attacks originating from the host operating system because the memory of the enclave is not encrypted from the point of view of the host operating system. Also, we are lacking currently the attestation solution for VBS enclaves, which would allow your application to verify that the enclave hasn't been tampered by an attacker with OS level admin at the OS level. So that's another weakness compared to SGX. So the bottom line is, if you care about these OS level attacks, and if you can cope with these restrictions, limitations of SGX, SGX is the way to go. On the other hand, you now have flexibility and freedom to use secure enclaves everywhere in all database SKUs, all the regions, if you are okay with these lower security guarantees, right? So this is just about giving you the choice and flexibility to use secure enclaves depending on your requirements, okay? With that, I want to show you a quick demo of VBS Enclave specifically. So in this demo, I want to show you how to enable a VBS enclave for a database in Azure SQL DB while we are in public preview. This method can change or evolve over time. Then I'll show you how to query encrypted columns, and I want to showcase a few capabilities on the way. And finally, we'll show that the user who doesn't have permissions to keys protecting your data, column master keys, we call them in Always Encrypted, such users cannot access plain text data, which is the key point in achieving data sovereignty, right? And controlling access to the data. So with that, let me try to switch to my demo environment. Any questions, by the way, from online or from the audience so far here? Okay. So what you see here is, of course, Azure portal. I'm connected to my sample database, demo database, and what I want to show you is how to enable a VBS enclave in this database. I want to call out that this is a database running on standard hardware, which is a key point here, right? You don't need any special so-called DC series hardware with SGX capability to use secure enclaves anymore. So to enable VBS enclave, I need to set a property which is called preferred enclave type, and I need to set it to VBS. And that's it. We are looking into ways of simplifying that and eliminating potentially even that step in the future. But for now, you need to set it. You can do that in Azure command line interface. You can do that in Azure portal. What it does under the covers, it places your database on a machine that is VBS ready. Not all our VMs are at the moment, but they are available very broadly in nearly all Azure regions already, right? So this is done now. While we are in Azure portal, I want to show you one more thing, which is relevant for the rest of this demo. In the same resource group as the database, I have Azure Key Vault, and in that Key Vault, I have a key called CMK1 that I will be using as a master key for Always Encrypted for protecting my data. And currently, there is only one user who has access to that Key Vault and to that key, and that's Diego. Okay, so now in the next step, our DBA Diego connects to the database with SQL Server Management Studio. And as you can see right here, this database has just one table, and this table has two encrypted columns. One is social security number, the other is salary. By the way, this is a table holding some HR employee information. These two columns are sensitive, therefore they are encrypted using the same key and using randomized encryption. And Diego connects, and he runs this query first. So he runs this query, and as you can see, the query returns encrypted data from the two columns that are encrypted. And the reason behind it is that right now Diego has connected without Always Encrypted enabled for the database connection that is associated with that query window. So if you go to the connection dialog, the Always Encrypted tab, Always Encrypted is not selected. So let's select it, let's reconnect, and after that, let's rerun this query again. So now, the behavior is different, right? Now, the client driver retrieved the data set from these encrypted columns and is attempting to decrypt the data. But the root key of the key hierarchy sits in Azure Key Vault, so the SSMS is prompting the user to sign in and authenticate to Azure Key Vault. So Diego authenticates, and because Diego has access to the key and the Key Vault, the client driver within SSMS can successfully decrypt the results and present plaintext data to Diego, right? So far, so good, but Diego now wants to do something more sophisticated with the data. He wants to run some more complex queries like this simple point lookup search. And this fails for now. And the error message informs us that although the database has a VBS enclave set up, the secure enclave functionality has not been enabled yet for the connection this query window uses. So let's fix that, again, by modifying the properties of the connection. By the way, I'm doing this here in SSMS through this UI, but under the covers, of course, there is a connection string dialog that if you are a developer, that's what you would be tweaking and editing to unlock Always Encrypted or Always Encrypted with secure enclaves. So let me select Enable Secure Enclaves for this connection. And one thing I mentioned before is that today, for VBS enclaves in SQL database, we do not have an attestation solution, which would allow, in this case, SSMS, this application verify that the enclave is, the DLL library running inside the enclave is the genuine enclave shipped by, library shipped by Microsoft, and the enclave is really VBS or SGX enclave. We don't have that yet, which is why I need to explicitly consent or express that I'm okay with using enclaves without attestation at this point, which results in this lower protection we discussed earlier. But still, it's more than nothing, right? And it gives you the flexibility of running rich queries, as you will see in a moment. So let's reconnect with secure enclaves here, and now hopefully we will be, or Diego will be able to run these three different queries. The first one is a point lookup search. The second is pattern matching, so we finding employees with a certain 4 digits of their social security number or national identification number, and the third query is a range query, finding employees with salary within the given range. Okay. So the enclave was used under the covers. It processed all the data and the clear after the data was successfully decrypted inside the enclave. That's why we were able to run these queries. One more thing I want to show you is more of a negative scenario. So here I have another user, Deborah, who is connected to the database. And let's say Deborah wants to run the same query. And Deborah is connected with Always Encrypted enabled for her connection. So when she runs that query, as in the case of Diego, Deborah is asked to re-authenticate to Azure. Now in the context of Azure Key Vault, she does that, but the query fails because, as you remember from the first, I think, minute of the demo, I showed you that the only user who has access to the key vault is Diego. Deborah does not have access to the key vault containing the master key. So that's why the query fails. So that illustrates that only authorized users can see the data, can query the data, can run computations on the data. So Always Encrypted, again, it's a feature that that gives you very high level of control. Who can see what? Who can see your sensitive data stored in specific columns containing that data? One thing that we didn't talk about, but I do want to mention that Always Encrypted, of course, has limitations, performance limitations, which is why you don't want to encrypt all your columns in your entire database. We can come back to that. Always Encrypted doesn't work with some features like certain replication capabilities. So you have to, very likely you will need to change your store procedures or your application a little bit to work around some limitations around query parameterization, for example. So there are some tweaks that you may need to do to your apps, and there are some capabilities that do not work with Always Encrypted today. There is a question, go ahead. Yeah. Yeah, so there is a question about backup restore, how that is impacted if we use Always Encrypted. The answer to that is actually a happy answer. There is no impact or very little impact. I'll tell you why. So the metadata about Always Encrypted, about cryptographic keys, is all part of the database. So when you take a backup of the database, that metadata is part of that, and then you can restore your database elsewhere, and the applications should be able to run the same queries. Of course, you will have to change the connection string, and you will have to make sure that your applications still have access to the same keys, protecting the same columns, but that should work seamlessly. And it does in a similar scenario, which is a failover, right? High availability group, or which we use in Azure SQL database, for example, to achieve failover. Your databases in Azure SQL DB move from time to time for various reasons, like failover situations, and that is seamless, or equally seamless as it is if you're not using Always Encrypted. So from that perspective, no impact. Okay?
How easy is it to remove the encryption?
How easy it is to remove encryption? As easy as to encrypt the data. So you have to, there is a process to, let's say you have existing column, which is plain text, you want to encrypt it, right? With Enclaves, you can run alter table, alter column statement. That might take time if you have a lot of data, but data at least is not moved from the database, and your data will become encrypted. There is a reversal of that, alter table, alter column without certain clauses, and that will decrypt the data.
So if we are using TDE encryption,
Mm-hmm.
is there any sort of best practices on whether to store the Always Encrypted it's somewhere else?
Versus TDE.
Or if you're using TDE as well.
Okay, so the question about best practices for Always Encrypted and TDE, please hold on to this question. I have a special slide for that. Okay, there's a question on screen also. Okay, how are the indexes affected when you use Always Encrypted features? So, well, with they are affected, but they work, right? And there is an impact on indexes, but it's mainly transparent to you. So you can create an index on an encrypted column to make sure that the performance of your queries is good, right? So there is from customers' perspective, for the majority of aspects at least, there is no impact. Under the covers, the index built on an encrypted column is very different from an index on a plain text column, but this doesn't have visible impact on how you do that. Let me move on, because we have a few other topics to cover, there is one more feature in the data in the confidentiality protection space, which is very related to Always Encrypted in terms of attack vectors it protects, and it's also quite new, and that's SQL Server in Azure confidential VMs. So this is not about PaaS at this point. So this is not SQL DB or SQL Manager instance. This is old-fashioned infrastructure as a service offering. You know probably about ability to run SQL Server in Azure VMs, right? It's a common thing people do as the first step in migrating to the cloud for existing apps. This is about a specific flavor of Azure VMs called confidential VMs. So we talked about SGX enclaves, right? With SGX enclaves, there is a chunk of memory within the process that is protected with hardware-backed keys, right? A confidential VM is similar, except it's much bigger than the enclave. The entire memory of the VM is encrypted with a hardware-backed key. And for that, we use AMD technology for a change called Secure Encrypted Virtualization. Okay, so what it does, it basically protects the entire content of the VM from host-level attacks, which could be launched potentially by malicious data center administrators, bootkits, rootkits, malware that could infect a host operating system. That's the idea. And of course, as in any VM, you can put anything and run anything on a confidential VM, any kind of a workload, right? But what's interesting in the context of our discussion here is running SQL Server. So running SQL Server in a confidential VM. Now, you basically, in this scenario, inherit the same benefits that apply in general for running anything in a confidential VM. Your data in use that SQL Server manages is suddenly protected from these OS level attacks that can originate from the host OS level. So you get a very high level of protection, additional defense in depth, in addition to many other capabilities that SQL Server, security capabilities that SQL Server provides. How do you enable that? It's basically very simple. There are one key step is when you create a virtual machine, you need to make sure that security type is confidential virtual machine. You need a special image, special meaning an image that is compatible with confidential VMs. As of now, SQL Server provides two such images, but we're actively working on expanding that library of images compatible with confidential VMs. And of course, you need to select a specific size of a virtual machines that runs on AMD hardware and has confidential VM capabilities enabled, right? So it's the same process, the same workflow for configuring SQL Server in a confidential VM as in a traditional VM with a couple of minor tweaks. Now, what I want to spend a little bit of time on addressing a gentleman's question from the earlier is about, so we have these three, or I also listed TLS here, different confidentiality protection technologies. Where should we use one versus the other, right? So one temptation we all should avoid is to, one way to misinterpret this table would be to look at the Always Encrypted column. Oh, it has checkboxes everywhere. That's great. I'm gonna use it and encrypt, 10,000 of my columns in my entire database, and I'm done. I'm protected from all the attack vectors listed on the left. That's not what we don't recommend that, right? Instead, we recommend using pretty much, all these technologies, or, well, you have a choice, of course, here, or decision point. Are you using a PaaS offering, or are you using IaaS offering? The last column here is applicable to IaaS only, of course. In general, our recommendation is to use transparent database encryption as the first level of defense for encrypting, protecting your data at rest. TLS is the solution for protecting data in transit that is flowing in and out of your database. And Always Encrypted, I hope that you can see the difference in size of these check marks here. These three attack vectors at the bottom, especially the two at the bottom, is where Always Encrypted excels. And the interesting question is, okay, so how about Always Encrypted and confidential VMs, okay? It's the same kind of a similar answer to, should I use Azure SQL database or should I use, let's say, SQL Server on IaaS in a virtual machine? If you have an existing application, an existing database, you cannot change your app, maybe you don't even own it, well, IaaS is not a bad place for it, and if that application hosts confidential data, then now you can easily protect the data with confidential VMs. On the other hand, if you can change if you're building a new application, can change it, Always Encrypted provides you a more granular control, if you will, and also more comprehensive. It protects your data against some additional attack vectors. So that's our guidance at the high level. Does that make sense? Did I answer your question you asked earlier?
It makes perfect sense, but it's not the question I asked.
Okay, sorry.
Specifically, when I talk about the storage of the certificates or keys that are used in the key vault, should we keep the key that's used for Always Encrypted in a separate key vault to the TDE key?
Oh, okay. So the question is, should we keep the key that is used for Always Encrypted separate from the key used for TDE? I think in general, yes. In general, yeah, or the answer is yes in general, because the assumption is that you will want to grant access to these two different keys to different actors, right? So specifically, TDE key is not for granular control. The only entity likely that will have access to the TDE protector will be your logical server, or the managed identity of your logical server, or the managed identity or your managed instance, right? Versus Always Encrypted is for granular control. You will grant access to the keys used by Always Encrypted to individual applications, users, and so on, okay? Okay, let me move on to the second but smaller bucket. Let's talk about technologies for protecting data integrity. So this is about how you ensure that some unauthorized users do not change your data maliciously, or if they change it, can you detect it? How soon can you detect it? And the technology that is one of its kind, the only in its category, is Ledger. And it's fairly new. So Ledger is about, it basically allows you to establish trust between your organization and your customers, auditors, stakeholders, and so on, right? And so what it does under the covers, it basically tracks the changes to your data and ensures that records these changes, and it cryptographically links those changes to make sure that your data is cryptographically verifiable, right? So there are two main use cases here. One is streamlining compliance audits. The idea here is that, let's say, auditor comes to your organization, literally within seconds, you can prove to that auditor that your data, what the auditor is currently looking at, it is what it is. It hasn't been maliciously tampered with through some back channels, right? That data has not been modified, or it has been, the changes are shown in the database, and the auditor can run forensic analysis to see what was changed by who. So this is like auditing feature on steroids, if you will, right? With cryptographic guarantees under the covers. The other scenario are multi-party systems. So Ledger in this scenario allows, it enables parties of these participating in these systems to trust each other, okay? The key concept in Ledger is a concept of a ledger table. It's a table like other tables on the surface, but under the covers there is some magic that happens. And there are two kinds of ledger tables, updatable and append-only ledger table. With an updatable ledger table, you can run normal queries, insert, update, delete. And what happens under the covers is that when a transaction makes a change to a row in an updatable ledger table, the historical version of this row are recorded in a history table. Does it remind you anything? Temporal, exactly, right? In fact, Ledger feature extensively builds on top of the temporal. Now is the difference between Ledger and temporal. So when a transaction makes a change on some records in a database, the database system hashes all these changes, and then every 30 seconds or so, it combines all the transactions together and hashes them together, and it generates what is called a block, a transaction block, and then it links these blocks cryptographically. Is that idea familiar to you? So that's what blockchains are about, versus we don't have this distributed ledger blockchain technology baggage here. It's all centralized architecture, which has many advantages, we believe, but we borrow some ideas from blockchains. And now, so we have this blockchain, a chain of blocks, and the last hash of this block at any point of time is like a digital signature of the database state. It's a digital footprint of the database. And now, every now and then, we upload these database digests to an external storage outside of the database. And it's a root of trust in this system. Now, later, an auditor or third-party customer can say, I want to verify the integrity of the data in this database. What happens then? The system recomputes all these hashes. We use Merkle-Lee data structures under the covers. And these hashes are compared with what is stored in this external trusted storage. And if they match, that's the kind of a binary mathematical answer that the data hasn't been tampered with. If they don't match, then it's a different story. That's an indication of likely tampering. Another flavor of ledger tables are append-only ledger tables, which only allow inserts and nothing else. So I think I have still time for a quick demo of Ledger. I'm going to show you basically here in this demo, the scenario is that we have a betting website that accepts bets for football or soccer games, matches, and a user of that site will create a bet, and an auditor will successfully verify the integrity of the Ledger data. Of course, this company is using the Ledger technology under the covers to build trust between themselves and the users of that website. And then I'll show you a hypothetical attack scenario. By the way, this is bug. This application uses SQL Server 2022 under the covers. There is a malicious DBA. He will tamper with the data, and then I'll show you how the auditor can easily detect it and do a forensic analysis. So let me switch quickly to my demo environment. Here's my Contoso Cup betting website, and I'm logged on as Peter. Peter is a user of the Contoso website. He actually will have more than one role in this demo scenario. He's putting 100 pounds, and he's from Belgium, so he believes that Belgium will win. I guess he doesn't know yet how poorly Belgium will perform in this World Cup. So he places his bet. So far, so good. Again, this bet record is appended to the append-only ledger table under the covers. Now we have an auditor here. His name is Michael. And so this company does routine audits of the database containing the bets ledger table. And that's what Michael does. So every now and then he runs this script, which basically calls a store procedure that verifies, that recomputes all the hashes, compares these hashes with what is uploaded to, in this case, Azure immutable Azure storage account. account where the digests are stored, and the recomputed hashes are compared with these digests. If they match, and they do in this case, that means that everything is fine and the integrity of the data has been preserved. The data hasn't been maliciously tampered with. However, now our Peter, the same guy who is a user of the website, he's also a DBA in this company. By the way, he has more than these two roles. Peter is also a program manager in my team, and he created this fantastic demo, and he's a PM for the Ledger feature also. But let's focus on these two roles. So he's a user of the website, and he's also a malicious DBA. So what he wants to do now, he basically runs this query. He finds the records, his actions on the website created. Here is the one for his last bet, £100 with a payout of £700. What he wants to do, he wants to increase his payout maliciously to, let's say, 10,000, right? So he runs a simple update statement, but it fails. It fails because the underlying table is an append-only table, and updates are simply blocked, okay? So that attempt fails, but he doesn't give up. He tries something more sophisticated now. So he has created a store procedure that literally tampers with the data in a data file, okay? So he runs this store procedure, and now he checks the results of that, and he can see now that his payout has increased indeed to 10,000, okay? And the select statement on a table, that's what it shows, right? Unfortunately for Peter, Michael is back, and Michael runs the same verification script which recomputes all the hashes, and now the script says, okay, something's wrong. The integrity of the data is not there. The hashes that got recomputed do not match with what was previously uploaded to the external trusted storage. In fact, that store procedure, that script produces the ID of the faulty transaction, and Michael can now run a simple forensic query here, copying this transaction ID. He will basically retrieve the records that are related to the transaction, and now Michael can see, okay, so this is a bad record of Peter that was modified, so of course Peter is now a prime suspect in the data tampering investigation, right? So that's the idea. It allows you to, Ledger allows you to easily detect malicious tampering with the data and run forensic analysis, and with that I can simply quickly wrap up. We talked about confidentiality protection, integrity protection. I guess we are out of time, but I want to leave a few minutes for questions. You guys will have access to this presentation. There is a bunch of resource slides that I put together in general on data sovereignty and each of the main technologies we talked about. There is no point in going through them one by one, but again, you will have access to this presentation. So if there are any questions, we have, I guess, 2 more minutes. There is something online as well, and I'm happy to stay here, and you can find me for the rest of the day at the booth, possibly as well. Thanks so much for attending.